Alright guys, I'd like to just take a minute today to talk you through a quadratic word problem. Now, the word problems that I'm going to be going through in this video and the other two are from a worksheet we had in class. Now, one thing to recognize is that in all of these, the equation is given to you. And so you're given a lot of information to start with. Now, one of the things that I want to highlight as we're working through this is just the idea that each question is asking for a specific thing. Now, often it will also give you information, and so we want to try to recognize what each question is asking and what each question is giving us to help us find what it's asking for. Alright, so let's go ahead and take this situation right here. The length of a rectangular swimming pool is 20 feet greater than the width. An equation used to model the area in terms of the width W is A of W. Now remember, this is just function notation. Remember, we talked about that a little while back. F of X equals W squared plus 20W. Now, where did this come from? Well, you could have actually made this because you know that area of a rectangle is length times width. And it just said that the length is 20 feet greater than the width. And so this could also be written as A equals W plus 20, right? Because the length is 20 more than the width times the W. And then if you distribute the W, you get W squared plus 20W. So you could have actually written that by yourself, and that may be expected of you at some point in time because you have done that on a celebration in our class. And so here you go. You've got the equation. Letter A asks us to identify the independent and dependent variables in the problem. All right, well, what depends on what? Well, hopefully you recognize that the area depends on the width. As the width changes, that will affect what our area is. So I'm just going to go down here. I'm going to say A width equals independent and A equals dependent. Now, along with this, I want to make sure that we have the idea that the independent variable is the x and the dependent is the y. Because when we think of a graph with the xy coordinate plane, it's important that you recognize which is which. So I'm going to just write that there because that'll become important when it starts asking me questions about what would this look like on a graph and x-intercept and y-intercept and all that stuff. All right, so let's go on to letter B. If the area is 525 square feet, what are the possible widths of the school? Of the pool, this school. So 525 we'll put in for the area, right? So this is asking what are the possible widths. So it's asking me for W, which means when I use my equation, W will still be a variable. That's what I'm looking for. What does it give me? It gives me that the area is 525 square feet. So that means that A is 525. Yes, it's giving me that information. So 525 equals W squared plus 20W. All right, so I recognize what's being given to me in the question and what the question's asking. So now I need to solve. You all know that when you have a quadratic, the first thing you need to do is make sure it's equal to 0. So I'm going to subtract 525 from both sides. And so then I'll have 0 equals W squared plus 20W minus 525. And so now I'm just going to factor. And so I'm going to put a W in front because W times W is W squared. My signs have to be plus and minus because the positive times the negative will give me this negative right here. And now I got to come up with the factors of 525. Now I'm not sure what those are off the top of my head, so I'm just going to pull up my calculator, and 525 divided by 5 is 105. So I know that that could be 5 and 105. But knowing that probably won't work too well with my 20 here. So let's go ahead and try another one. Well, if 105 goes into it, then there's got to be another 5. So let's take 525 and let's divide it by 25. And so there's another factor, 21. So 25 and 21. Now I feel like I'm getting closer, but 25 and 21 aren't going to give me that 20 either. So what else goes into 21? Well, 7 does. So let's try 525 divided by 7. All right, so 75. So 7 and 75. All right, well, that's too big again. So we just got to keep looking through till we can find two things that multiply together to give us 525. Now, if this is taking too long for you and you're really getting annoyed with the fact that you can't figure it out, you can always just use the quadratic formula. All right? But, you know, I happen to know that since 3 and 5 both go into that 15 goes into that. So I'm going to try 525 divided by 15. And, oh, I get 35. So 15 and 35. And please note that if I go plus 35 and minus 15, that when I check the inside and outside, that's 35W. And that's minus 35W, or sorry, minus 15W, which goes together to give me 20W. So that checks out. So I've got it factored, which means that W plus 35 equals 0, or W minus 15 equals 0. So W equals negative 35, and W equals 15. The only one of those that makes sense is the W equals 15. So if the width is 525, or so the area is 525, that means the width has to be 15. Now, letter C says, what significance do the values in part B have as points on the graph? Well, once we moved it over, we could probably consider the fact that the y is equal to 525. These are actually both points on the graph. I wouldn't really call it the x-intercepts because y, the area, was not actually 0. And so I wouldn't call this, I wouldn't really say that it's the x-intercepts. I would just say that it's 2 points on the graph, right? You've got negative 35, comma 525, right? Because that was the y value. That was A. And then you've got 15, comma 525. All right, and so I would just say for letter C, they're both points on the graph. All right, then we go on to letter D. Do both of these values make sense? And we kind of already answered that question. No, because the width can't be negative. And then last of all, is there a y-intercept? Well, to get the y-intercept, well, we always make x equal to 0. So let's make x 0. So we go AW equals 0 squared plus 20 times 0. So A equals 0. So, well, I guess that should make sense. If the width is 0, the area should be 0. So there you go. And that answers the, I guess if I put that in, that would be the y-intercept. So what does this point represent? No width equals no area. So there you go. I hope that makes sense. Main points here is information from the question is used. And then secondly, the fact that here we didn't actually put 0 in for A. We used our method of factoring to solve it, but this is actually not an x-intercept, right? Because the y value, the A, is 525 there. It's not 0. And so important to recognize those are points on the graph, but not necessarily the x-intercepts. All right? So hope that was helpful for you, and I'll go do another one.